Tech Talks Education. Let us continue with the formation of covalent bonds in covalent compounds. Formation of covalent bonds in covalent compounds. So let us look at how this is done. In fact, we are just continuing because we had looked at the formation of covalent bonds between hydrogen and oxygen to form water, and the formation of covalent bonds between carbon and oxygen atoms to form carbon dioxide. So let us look at another one, that is the formation of covalent bond between nitrogen and hydrogen to form ammonia. So what do we start with? We start by looking at the formula of ammonia. NH3, nitrogen atomic number 7, configuration 2 to 5. The valency is 8 minus 3 since it is a non-metal. So the valency is, in this case, 3. Then hydrogen atomic number 1, electron configuration 1, then it is 2 minus 1 since it is a non-metal, and the valency is 1. So these 3 will come here, and that is the formula of ammonia, NH3. Then nitrogen, we have already seen that a nitrogen atom atomic number 7, configuration is 2 to 5. Then hydrogen atom atomic number 1, the configuration is 1. So a nitrogen atom has got 2 shells and hydrogen atom has got only 1 shell, meaning that a nitrogen atom is larger than a hydrogen atom. Now, let us draw. We have 1 atom of nitrogen, it's here, and we are having 3 atoms of hydrogen, much smaller, 1, 2, and then 3. We expect, in this case, the hydrogen atoms to be having the same size. Hydrogen, 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 the electron configuration is 1, only 1 electron in its outermost shell. So let us use this. This one also 1 electron, also this one, 1 electron. Meanwhile, the nitrogen atom has got 5 electrons in its outermost shell. 1, 2, or let us use crosses this time. 1, 2, 3, 4, 5 electrons. So we are saying X stands for the electrons of the nitrogen atom. Meanwhile, this circle stands for electrons of the hydrogen atoms. So let us see, let's go to contribution of the bonding electrons. We are adding them together as we have been doing. So we are just adding them. In this case, hydrogen has got a valency of 1. So we expect it to contribute 1 electron for bonding. Then this hydrogen atom also gives 1 electron for bonding, and this hydrogen atom also gives 1 electron for bonding. Then in this case, the nitrogen atom will respond by also contributing 1 electron for bonding with each of these hydrogen atoms. A total in this case of the nitrogen atoms of electrons being what? 3 contributed for bonding by the nitrogen atom, which is equal to the valency of nitrogen. So when this happens, then we get a nitrogen atom being bonded to 3 hydrogen atoms. Let me try to make them have almost the same size here. And here we also have another one. So this is how it looks like. Hydrogen atom, hydrogen atom, a hydrogen atom, and this is the nitrogen atom. So let us try to see, in between this hydrogen atom and the nitrogen atom, there is one electron from the nitrogen atom and an electron from a hydrogen atom. A nitrogen atom gives an electron, a hydrogen atom also gives one electron for bonding. This one also, a nitrogen atom gives one electron for bonding. The hydrogen atom also contributes one electron for bonding. What the nitrogen atom remains with is 2 electrons which are not used for bonding. So if we consider the outermost shell of the nitrogen atom, it will be having 1, 2, 3, 4, 5, 6, 7, 8 electrons independently. And for this hydrogen atom, it will be 1, 2 electrons. It is also full. This hydrogen atom is also full. This one here, the outermost electron, the outermost shell is also full. So if this is our nitrogen atom, we shall have a covalent bond formed between this nitrogen atom and this hydrogen atom, because we say that each bonding pair of electrons is equal to a covalent bond. So there is one hydrogen atom here, there is another nitrogen atom with a hydrogen atom here, and another one here with a hydrogen atom. So this is the structure of ammonia in this case, when hydrogen and nitrogen atoms combine. So this one is a covalent compound. Remember, there has been equal sharing of the number of bonding electrons between the atoms, and then, there was equal contribution, and now what? Sharing. It is not all about formation of ions, but contribution of the bonding electrons and then sharing of those electrons. Equal contribution and then sharing. So this space here may not be enough for our other example. So allow me to remove this one here, and then we create space for another example. So we are going to look at our last example possibly. That is our number 4, or I don't know whichever number, but now we're going to have carbon and hydrogen to form methane. Oh, let us see the formula of this compound here using the valencies of the component elements. So we have carbon and we have hydrogen. So carbon has got atomic number 6, configuration is 2 to 4, the valency is 4. A hydrogen atom has atomic number 1, configuration 1, the valency is also 1. So they will exchange valencies, and when they exchange valencies, then the formula of the compound formed is CH4, and that's what we call methane. So we shall have to draw this. A carbon atom is larger than the hydrogen atoms. So we have 4 hydrogen atoms and 1 carbon atom. So let us have the carbon atom here. 1 carbon atom. And next to it is 4 hydrogen atoms. 1, 2, 3, 4. Oh, let us reduce the size of this one here a bit. 4. So I have 4 hydrogen atoms. We take the shape to be, or the size rather, of these atoms to be the same. And then this is the carbon atom. So let us fill the outermost shell. For the hydrogen atom, there is 1 electron in the outermost shell. Meanwhile, for the carbon atom, we have 4 electrons in the outermost shell. So we are adding these ones here together. And then the valency of hydrogen is 1. So each hydrogen atom will release only or will contribute 1 electron for bonding. And then the carbon atom will give 1 electron also for bonding with each hydrogen atom. So a total of 4 electrons will be contributed by the carbon atom, since the valency of carbon is 4. So what they form is, this is the central atom, the carbon atom. It is bonded to 4 hydrogen atoms. 1, 2, 3, and the 4th atom is here. Hydrogen, 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 hydrogen. So at these points here, we have the electron produced by the carbon atom and that one by the hydrogen atom. That of carbon, that one of hydrogen, that of carbon, that one of hydrogen, that of carbon, and that one of hydrogen. So in this case, X is the electron of the carbon atom. Meanwhile, the circle is the electron of the hydrogen atom. So we have this carbon atom and it is bonded to 4 hydrogen atoms. And here where there is a double bond here, where we have a bonding pair of electrons, that one is a single covalent bond which has been formed. Hydrogen, 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 and hydrogen. This is the structure of what we call methane, and this is how methane is formed. So we just only add these atoms here together. We show these signs here. This one shows that we are making them to bond, but in the bonding they contribute the bonding electrons and then they share them. So when they are sharing, they look like this. So in this case, we have a lasting attraction between these atoms because their outermost shells are sharing the bonding electrons. So that is how methane is formed from carbon and hydrogen. Tech Talks Education. Thank you for watching.